Good morning. Myself R.SRIVEL, working as a assistant professor in Shanmugha College of Engineering. So I'm going to give a small introduction about microprocessor and microcontroller. So now we are going to discuss about that Unit 2, 8086 System Bus Architecture. So I have taken this topic from from that book Geren Gibson, book name that is Microcomputer System 8086 and 8086 Family Architecture, Programming and Design, second edition, Britain's Hall of India. So this is the pin diagram of 8086 microprocessor. So it consists of an 40 pin IC. So in that, first we are going to discuss about that supply, ground, clock, and then reset. So supply pin, that is a 40 pin, is a supply, that is VCC. So here you are going to give a 5 volt supply. Then in ground, so we have a 2 ground, 1 as well as 20, that is a ground pin. Then we have a clock signal. So clock signal, based on that clock frequency only, that clock frequency only, that time period for every execution of that instruction will takes a particular time, that is depend upon that clock frequency. So here we use that 19th pin for that clock signal. Then reset. So when we press the reset, so it will reset the register, segment registers, and then flag. So code segment value will be that FFH, and then instruction pointer will be 000H. Next, we are going to discuss about that multiplexed pin, that is address as well as data pin. So 8086 consists of a 20-bit address line and then 16-bit data lines. So in order to reduce the number of pins, so we are going for that multiplexing, so that address as well as data lines are multiplexed. That is, from data lines, that is starting from AD0 to AD15. So AD represents address as well as data lines. So address line, that is from A0 to A15, data lines from D0 to D15. 16-bit as well as this 16-bit address lines are multiplexed into from pin number 2 to 16, then pin number 39, which reduces the number of pins in the IC, 8086 IC. So how we can able to differentiate mean with the help of an address latch enable. So when the address latch enable pin is 1 mean, so it contains that address, the particular pin. When ALE pin value is 0 means it contains the data. So this can be used to separate address as well as data. It is called as an address latch enable. Next we are going to discuss about that interrupt pins. So in that we are going to have that non-maskable interrupt, that is called as an NMI. Then interrupt request, that is INTR, that is connected to that pin number 18. Then interrupt acknowledge, that is pin number 24. Next, DMA signals. So we are going to have the 2 pins, that is one for DMA request, that is called as an hold. Then DMA acknowledge, that is called as an HLDA, that is connected to the pin number 30 as well as 31. Next, address as well as status pins are multiplexed here from A16 to A19. So we have an 38 to 35, that is a multiplexed pin. Address bits, that is A19 to A16, and status bit S6 to S3. So status pin, that is denotes that S3 as well as S4. When it is 00 means the function that is going to execute that taken the data from extra segment. 01 means stack segment. 10 means code segment. 11 means data segment. So S4 as well as S3, which is used to indicate that which segment is accessed currently during the bus cycle. Then BHE bus high enable, so which is used to select whether it's an even order address as well as odd order address. So here you are going to use that BHE as well as S7. So 00 means whole word, it is a 16-bit this data is going to read. Then 01 means high byte from odd order address, and then 10 means that is low byte from even address. 10 means that is 11 means that is no selection. So in 8086 we are going to have two modes. One is minimum mode, another one is maximum mode. Minimum mode means, so when pin number 33 is connected to logic, that is VCC, means so it will act as a minimum mode. When maximum mode means, so pin number 33 that is connected to 0 volt means so it will act as a maximum mode. So these are two pins we have. One is minimum mode as well as maximum mode. So in minimum mode we have two DMA pins, then write, memory or IO operation, data transmit or receive, data enable, address latch enable, and interrupt acknowledge. In maximum mode, so we have status signal, queue status, then request as well as grant, then log signal. So minimum mode, first we will discuss. RD bar represent the read signal. We can read the data from the memory and to the memory. Then write, we can write the data from the memory and then to the IO device. So in order to separate memory as well as IO operation, we are going to have m/IO bar. When this pin 28 pin value is 1 means, so it is going to perform that memory operation. When it is 0 means it is going to perform input output device operation. Next, DT/R bar, data transmit or receive. So we are going to transmit, that is we are going to write the data to the microprocessor or to the IO device. That can be done with the help of DT/R bar. Then DEN, that is a data bus enable. Next we have S2 bar, S1 bar, S0 bar. So that denotes the status signal. So that is 00 means, so that is interrupt acknowledge. 001 means read IO port. 010 means write out input port. 011 means halt. 100 means code access. 101 means read memory. 110 means write memory. 111 means non-passive. So, maximum mode. So maximum mode, that is used for multiprocessor communication. So in that multiprocessor we are going to have the DMA process. So for that we are going to have the two pins 31 as well as 30. One is RQ as well as GT0. So RQ, that is called as a DMA request. GT0, that is called as a DMA grant. So we have two channels here. Then lock output, that is used to lock. So that is used to lock the peripherals of the system, activated by using the lock prefix on any instruction. Then QS0 as well as QS1, that is used by numerical coprocessor. So 00 means Q is idle, 01 means first byte of opcode, 10 means Q is empty, 11 means subsequent byte of opcode. So these are the minimum mode signals, AD0 to AD15, A16 to A19. So that is address as well as data bus, address as well as data bus. Status bus. RD bar, read from memory as well as IO device. Ready signal, that is ready signal. M/IO bar, select memory or IO device. WR bar, write to memory or input output device. ALE, address latch enable. DT/R bar, data transmit or receive. DEN, data bus enable. BHE, bus I enable. INTR, interrupt request. NMI, non-maskable interrupt. Reset, INTA, interrupt acknowledge. Hold, that is for DMA signals in minimum mode. DMA request, HLDA, DMA acknowledge. What are the other pins? We have test signal, test pin, that is tested used by wait instruction. M1/MX bar, that is minimum mode / maximum mode. So minimum mode, so we have to connect this pin to VCC. Clock pin, that is used for basic timing signal. VCC, that is used for power supply. Ground, that is for ground connection, 0 volt. Maximum mode, AD0 to AD15, address as well as data bus. Then same A16 to A19, address as well as status bus. Handshaking for data read as well as write. RD, read from memory as well as IO device. Ready, bus I enable as well as S7. Then status signal S0, S1 as well as S2. Next, interrupt signal, INTR, interrupt request. NMI, non-maskable interrupt. Reset, bus access control. RQ/GT0, then RQ/GT1, request as well as grant for bus access. Lock, used to lock the bus activated by lock prefix on any other instruction. Then Q status QS1, QS0, test signal, minimum mode / maximum mode. When it is connected to maximum mode means, so it has to connect to ground. Clock, VCC, that is power supply, then ground connection 0 volt. Thank you.